to welcome you all to Berkeley and to the introduction to the From Data to Knowledge workshop. We're very pleased to have you here. We have a speaker who will also offer his welcome. This is Horst Simon. Many of you know as one of the co-authors of the Top 500. He was twice winner of the Gordon Bell Prize. We know him locally now as the Deputy Director at Lawrence Berkeley National Lab. Before that, he was Director of NERSC. So I'll leave it to you, and then I'll come back and give you a couple more words.
Thank you, Josh, and good morning. Welcome to Berkeley. It's a perfect time, and it's the perfect workshop at the perfect time. The reason why that is because we've just seen here locally a string of very exciting events. With respect to big data, of course, everybody's talking about big data, but in Berkeley, we won actually two very significant grants recently. So in the Electric Engineering Computer Science Department, the AMP Lab got funded by NSF. This is an expedition for algorithms, machine, people, which will really look from the computer science point of view at big data. At the same time, at the lab at Lawrence Berkeley National Labs, DOE awarded us the SDEF Center, that's for Scientific Data Analysis and Visualization, another DOE SciDec successor program. So these two programs happened just within the last couple of months. And then on top of that, that's not directly related to data, we were very successful in the competition for the Simons Foundation, the Theory of Computation Institute that will be started here in Berkeley July 1st. And there's actually, as it turns out, a dedication ceremony in the next couple of weeks, May 23rd, with Jim Simons and arriving to officially send us a check, so to speak. So lots of things happening in Berkeley with data, and so I'm very pleased that Josh has been working at this for many, many years, and we've been collaborating on this. And I think this is important because I think today everybody's talking about big data, but the astronomers have been dealing with big data forever. And they always had big data. It's always probably 5 years ahead of the time. And so I think this workshop is particularly important because, in a sense, looking at streaming data, looking at real time, and looking at machine learning techniques to find actually scientific knowledge and new discovery in the data is very timely, and I think is, again, years ahead of the rest of the public excitement about big data. So with this, I'm very pleased that all of you gathered in Berkeley and you're coming together. I want to thank Josh for putting together such a terrific program that unfortunately, of course, I won't be able to completely enjoy, but I'm at least trying to listen to a few talks here. So I wish you a very successful week. I hope you will learn something. We exchange information. Computation, data analysis, and science are going together very intimately now in the future. And I think this workshop is one of those efforts to really show the value of computation, data analysis to make scientific progress. So good luck for the week and enjoy your conversations, discussions, and presentations.
Okay, so I said that I would come back. I want to sort of echo what Horst just talked about in the context of big data and ask the question of, to start off, why are we here? And where does this workshop fit into sort of the larger academic and industrial ecosystems in the context of big data? As many of you know, the public is now unavoidably confronted with the notion that something has got to be done with this growing onslaught of data. And the government is putting some not insignificant numbers of chips into the pot now in a way that is very public, and I think that's good for all of us. The government, in some sense, is playing catch-up in a public way, although they've been funding through the National Science Foundation and DOE and such, and NIH for a number of years. Businesses, of course, have been dealing with the big data flood for many years, and this notion of how you make fruitful, wonderful things happening in the context of this fire hose was captured, I think, well in this cover from The Economist a few years back. Many of you, of course, have been thinking about big data issues for a number of years. This is just a chart from Google Trends, and you can see that machine learning at least in the public's mind, because this is what the public are searching for, has been sort of losing ground while big data has been really kicking up over the last couple of months. And even before there was Google Trends, and even before there was Google, many of you in this room were actually working on the important issues that have enabled people to be able to deal with the kinds of problems that we have at hand. So I applaud you all for that, but before we get too excited about our sort of rising stature in the public's eye, let's remember that other search terms like Justin Bieber vastly outswamp anything else that we're working on. So we're still a very minor player in the public's view. It's clear that big data techniques and analysis tools have also been growing in the domain sense. So they've moved out of computer science, moved out of theory, and started to come into practice. This is a very nice website called Bookworm that allows you to do search terms on various postings on the archive. And what I have is a couple of search terms from AstroPH, which is what the astrophysicists use to post their papers. And what you can see on a various different sort of trend lines here is that more or less our use of machine learning and random forest, for instance, and neural nets is kind of all been burbling along and starting to take off. At least some of the newer techniques are starting to get more and more use. But if you look at the y-axis, you'll notice that it's a very paltry amount of use at this point. Now, obviously, not all big data problems require sort of advanced analytics. Sometimes we can deal with them with sort of better hardware solutions. But I think the point here also to recognize is that big data and big data solutions is really just starting to enter into the vernacular in a quite common way, not just in astronomy, but across the physical sciences and then beyond. One of the things that I think brings us all here is not this sort of tagline of big data, but instead it's this notion of streaming data. And when we add the component of streaming, something interesting happens. There is an urgency and an immediacy to getting these solutions and deriving knowledge that might not be there if you're dealing perhaps with a static data set, or you have all the time in the world to derive your answer. When you think of it from an industry perspective, if you're landing on a page and you need to have some idea of what to show somebody, you might need to do some major data mining and have the results pop up in 100 milliseconds. So there's that kind of urgency. If somebody is off using your credit card and there is real money at stake, there's an urgency in being able to obviously identify when fraud is happening. And then, of course, there's other issues that the government are interested in identifying anomalies. In astronomy, we're starting to use random forests and other techniques to be able to make sense of an onslaught of data to identify in near real time exploding stars. You'll hear more about that in this afternoon session. And it goes on and on and on. When it comes to streaming data, we need to know what we've got and what actions we need to take. And there are real sort of implications for being wrong about something, just as there are implications for being right and identifying the thing that you were actually looking for. In the spirit of streaming data, what we thought would be a cute sort of intro to our notion of pulling together lots of data and trying to make some sense of that, we wrote a little tool to be able to capture speech. And so everything I've been saying so far has been pushed over to a Google speech-to-text API. We're pushing that into a Google Fusion table. And then we have a tag cloud that's being generated in real time. I'll see if I can demo this. See how this goes. You can see what's being pulled over. I'll show you the website. This is at cloud.cftd.info. So I haven't said all that much. Of interest. I guess speech, right? That's not so bad. Let's see what else. Not so much new there. But what we're going to try to do is have this more or less running throughout the conference, if people are okay with that. We're not actually saving and recording this speech and sending that to Google. We're saving that for later. But you'll see that this tag cloud will actually evolve with time. And there should be a Twitter feed that we should be able to see here as well. I don't think that's coming up quite like we wanted to. Let's see what happens here. No, it's not there now. But the important point here is that just because we're grabbing lots of data, and just because we're trying to do, NLTK on it, and we're trying to actually try to make some sense of it, it doesn't mean that we actually do understand what it is that we have. Just grabbing data, aggregating it, visualizing it doesn't mean you understand and you've derived actual knowledge from that. And here's an example of what we had a couple days ago, where we're actually doing Twitter feeds on the top sort of tag clouds. This is kind of interesting in terms of joining streams, but it doesn't mean that we've actually learned much from it. So one of the important points of streaming data is that we all have to deal with messy, heterogeneous, and incomplete data sets. And how we make robust, even if it's only approximate statements quickly about such data, is really an open question, both from a practical standpoint and then also from a theoretical standpoint. And importantly, what are the quantifiable impact on the follow-up resources? That is, if we make a statement perhaps about credit card fraud and we have to get a bunch of people involved, those people's time are actually something that we can quantify. And if we're wrong too often, then we've completely killed the system. So in the context of false positives and false negatives and calibrating the so-called ROC curve, this is very, very important. So it's not just keeping up with the data, it's trying to make real, robust knowledge statements about it. Okay, so let me start off this conference basically with the supposition of what I think we have here. Our idea, and I think many of you have also signed up to this as well, is that domain scientists, theoreticians, people from industry are all going to be able to benefit from exposure to a diverse set of practices in this sphere. The idea is that the techniques that are employed perhaps in one domain aren't readily available or even known to another domain. And so one of the goals, of course, is to try to transfer some of that knowledge over the course of this week and in our interactions. The fact that all of you are here from such a diverse set of backgrounds, I think, is reason for me to already declare this conference or workshop a success. So I guess we shouldn't go home. But I want to sort of end with a bit of an admonition here, is that there's a particular onus on all of you to recognize that while there's this wide knowledge base of those in attendance, not everybody is up on all the terminology and jargon from every other domain. So in your talks, in coffee breaks, or when you're discussing posters, over lunch, over drinks at night, don't presuppose too much about the people that you're sitting across from. Start off simple as you would, not really knowing where somebody comes from, and then try to figure out what are the deep questions that everybody's asking, and try to see what kind of connections you can make to them. Your job is to be didactic, to be patient, and to speak frankly. So with that, I'll welcome you again to Berkeley and for the start of the conference. I'll now turn it over to Barian James, who is chairing the first session.
For algorithms, machine, people, which will really look from the computer science point of view at big data. At the same time, at the lab at Lawrence Berkeley National Labs, DOE awarded us the SDEF Center, that's for Scientific Data Analysis and Visualization, another DOE site.
Leave it to you, and then I'll come back and give you a couple more words.
Thank you, Josh, and good morning. Welcome to Berkeley. It's a perfect time, and it's the perfect workshop at the perfect time. The reason why that is because we've just seen here locally a string of very exciting events with respect to big data. Of course, everybody's talking about big data, but in Berkeley we won actually two very significant grants recently. So in the Electric Engineering Computer Science Department, the AMP Lab got funded by NSF. This is an expedition.
As one of the co-authors of the Top 500. He was twice winner of the Gordon Bell Prize. We know him locally now as the Deputy Director at Lawrence Berkeley National Lab. Before that, he was Director of NERSC. So I'll want to welcome you all to Berkeley. and to the introduction to the From Data to Knowledge workshop. We're very pleased to have you here. We have a speaker who will also offer his welcome. This is Horst Simon. Many of you know